Hello students, I am Dr. M. Velumani, Assistant Professor in the Department of Civil Engineering. In this video, we will receive a important topic from Design of Steel Structure, namely properties of steel, types of steel section and the basic concept of limit state design. This section is designed as a quick and clear revision, so watch till the end. Introduction to steel in construction. Steel is one of the most widely used construction materials, next only to concrete. The main reason for its high strength to weight ratio, which means steel structure can carry a heavy loads with relatively smaller cross section. Unlike concrete, steel has a uniform material properties which makes the analysis and design more reliable. Steel can resist the tensile, compressive and shear force. Another important advantage is ductility. Before failure, steel undergoes a large deformation, giving a sufficient warning. Steel structure can be easily fabricated, transported, assembled, disassembled and reused. Because steel is a recycle, it is also considered suitable construction material and form a backbone of modern infrastructure such as bridges, towers and industrial buildings. Mechanical properties of steel. Now let us understand the mechanical properties of steel. The yield strength mentioned by Fy is the stress at which steel starts deforming plastically. Behind this point, permanent deformation occurs. The ultimate strength F(U) represents the maximum stress steel can withstand before failure. Steel has a very high modulus of elasticity, approximately 2 into 10 to the power of 5 Newton per mm square, which indicate its stiffness. Ductility is measured by the percentage elongation and indicate the ability of steel to undergo deformation without cracking. Physical property of steel. Coming to the physical properties, steel has a density of about 7850 kg per cubic meter, making it heavier than concrete but much stronger. Steel expands with the temperature with a coefficient of thermal expansion close to the concrete. This making a steel compatible with the concrete in RCC and composite construction. Steel is a good conductor of heat and electricity and has a high melting point of around 1500 degrees Celsius. It is a homogeneous material, meaning its property are the same in all the direction, which is design is a calculation very easily. Due to its homogeneous material and magnetic properties, steel is widely used in both structural and industrial applications. Advantages of steel structures. Steel is offer many advantages such as high strength, fastener construction, flexibility in design and suitably for long span and tall buildings. Fabricated controlled production ensure the uniform quality and steel structure perform well under dynamic and impact loads. Types of steel sections. Steel is available in various standard roll sections, each designed for the specific function. I section and H sections are commonly used as a beam and column. I section are effectively in buildings, while H section with wider flanks are preferred for the column and heavy loads. Channels and angle are economical and widely used in trusses, bracings and purlins. Angles can be equal or unequal or easily to fabricated and connected. T sections are usually obtained by a cutting I section and are usually secondary members. Hollow sections such as circular, square and rectangular sections are highly efficient in compression and torsion. Limit state design concept. Finally, let us discuss the limit state design method which is followed in IS 800-2007. This modern design philosophy ensures the both safety and serviceability through the structural life. It is the use partial safety factor for the load and material to account for the design concept. Two main limit states are considered. First one is the limit state of strength, ensure the structure does not collapse due to the bending, shear, buckling and fractures. Second one is the limit state of serviceability, ensure the acceptable deformation, vibration and crack controller. Design principles of in limit state method. Design loads are equal to character load into partial safety factor. Design strength is the character strength divided by material factor. Factor load is considered for the extreme conditions. Multiple load combinations check the dead load, live load, wind load and earthquake load. Serviceability checks with the unfactor loads, ensure the ductility and reduce the in design. IS codes previously value for the safety factors and the design strength. Structural safety ensure the against the strength. Thank you and happy learning.